If you tried to design the worst possible apex predator, you'd probably come up with the Greenland shark. It swims at the speed of a slow jog. It is blind in both eyes. Its meat is so toxic it will get a sled dog drunk. There's just one problem with this design. It works. The Greenland shark has been doing it for 400 years, per individual. 150 years before a Greenland shark is old enough to mate. The United States has not been founded yet. By the time it reaches sexual maturity, the Napoleonic Wars are already in the history books. By the time it dies of old age, your great-great-great-grandchildren are talking to refrigerators. This is not a metaphor. According to a 2016 paper in Science by Julius Nielsen and colleagues, the largest Greenland shark in their dataset was aged at 392 years old, plus or minus 120. That is the single longest lifespan ever recorded for a vertebrate. To understand how an animal this slow, this blind, and this strange ended up running the Arctic deep, you have to start with how anyone managed to date one in the first place. Sharks do not have growth rings in their bones, because sharks do not really have skeletons, or cartilage. For most of the 20th century, nobody had any idea how long a Greenland shark lived. The math suggested they might live a long time. Nobody could say how long. Nielsen's team went around the cartilage problem entirely. They went to the eye. The lens of a vertebrate eye is built layer by layer over the animal's lifetime, starting in the embryo. The innermost core, the nucleus, is laid down before birth and never gets replaced. Whatever carbon is in that nucleus, when the animal is born, stays there. The team collected lens nuclei from 28 Greenland sharks, caught as bycatch in the North Atlantic, and ran the cores through radiocarbon dating. The carbon-14 signature tells you when the animal was born, because nuclear weapons testing in the 1950s and 1960s left a sharp bomb pulse signature in the world's oceans that scientists can read like a watermark. The biggest specimen, a female just over 5 meters long, came back at 392 years old, with an error range between 272 and 512. Either way, this was an animal that had been alive since before the founding of most modern nations. The youngest sharks in their sexually mature group were around 150 years old, which means a Greenland shark reaching sexual maturity today was born around the time of the American Civil War. That alone would make this animal worth a video. The lifespan is just the entry ticket. Now move to the eyes, because they are the strangest design feature on this shark. Nearly every adult Greenland shark in the wild has a parasite hanging off its eyeball. According to surveys cited in the marine biology literature, the prevalence runs at roughly 99%. The parasite is a copepod called Omatocoita elongata, a small crustacean about 5 centimeters long that attaches to the cornea by burying its mouthparts into the surface of the eye. Once it grabs hold, it stays there for years, possibly for the rest of the shark's life. It feeds on the corneal tissue. The cornea scars, clouds over, and stops transmitting light. The shark goes effectively blind. For most animals, this would be a death sentence. Vision is the dominant sense in nearly every predator the ocean has ever produced. You hunt what you can see. You ambush what you can see. You read terrain with what you can see. A blind apex predator should not exist, and yet the Greenland shark, parasitized in both eyes for the bulk of its adult life, keeps eating. It keeps growing. It keeps living for centuries. Whatever sense it is using to find food, the eyes are not load-bearing. The Greenland shark hunts almost entirely with its other senses. The ampullae of Lorenzini, the electroreceptor pits on a shark's snout, can detect the bioelectric field of a heartbeat at close range. The lateral line picks up pressure waves in the water from any nearby movement. The olfactory bulbs in the Greenland shark's brain are unusually large for a shark, suggesting that smell does a lot of the work the eyes used to do. Researchers studying the species have described it as essentially a swimming nose with electrical sensors on the front. The eyes, by the time the shark is 50, are barely participating. Now stack the speed problem on top of the blindness problem. A 2012 study by Yuki Watanabe and colleagues attached accelerometers to Greenland sharks in the wild and recorded their swimming behavior over weeks. The result is one of the most counterintuitive numbers in marine biology. The cruising speed of a Greenland shark is around 0.34 meters per second, which works out to slower than a human can walk. Its tail beats once every 7 seconds at cruising pace, the slowest rate of any fish ever measured. By any reasonable definition, it is the slowest fish in the ocean. Which raises the obvious question: how does a blind shark that swims slower than a person find anything to eat at all? The diet is the part that broke a lot of biologists' heads. According to a 2019 study in Frontiers in Marine Science led by the same Julius Nielsen, who has more or less built his career on this animal. The stomach contents of Greenland sharks pulled out of the North Atlantic include exactly what you would expect from a slow blind shark, and then a series of things that make absolutely no sense for one. Halibut, cod, Atlantic char, crustaceans, squid, all of that is fine. Slow scavenger food. A blind shark cruising near the bottom could plausibly find dead fish. But the stomachs also contain seals, whole seals, ringed seal, harbor seal, hooded seal, all of them faster swimmers than the Greenland shark by a wide margin. They contain reindeer, whole reindeer. There is a documented case of a Greenland shark pulled out of the water with the entire torso and forelegs of a reindeer in its stomach, which biologists assume fell through ice or was caught while swimming across a fjord. They contain polar bear remains. The leading theory is scavenging from a corpse, but at least one Greenland shark on record had eaten the polar bear piece whole. If you are enjoying this strange shark as much as I am, hit subscribe. More stories like this on the channel every week. The shark is scavenging on a massive scale, swallowing whatever falls into the deep from the world above. And it is, somehow, also catching live prey that should outrun it without trying. The current best guess for how this happens involves sleeping seals. Seals haul out on ice, but they also nap in the water, hanging motionless near the surface or in the water column. A blind slow shark cannot catch a swimming seal. A blind slow shark drifting up from below at 1/10 of a mile per hour might very well catch a sleeping one. Especially with electroreception zeroing in on the heartbeat from a distance the seal cannot detect in its sleep. The shark turns its biggest weaknesses, the slowness and the silence, into the only advantage that matters when ambushing prey that is not paying attention. Pull on a different thread for a moment. The Greenland shark's flesh is, on its own terms, chemically aggressive. The tissue contains very high concentrations of urea and trimethylamine N-oxide, two compounds the shark uses as osmotic balancers to keep its cells stable at the temperatures and pressures of the deep Arctic. Eat that tissue fresh and your body converts the trimethylamine N-oxide into trimethylamine, the same compound responsible for the smell of rotting fish. Except this version is concentrated enough to cause neurological effects in mammals. Sled dogs in Greenland that have been fed raw Greenland shark scraps have shown symptoms that local hunters describe as drunkenness. Loss of coordination, glazed eyes, staggering. The veterinary term is shark meat intoxication. The dogs recover. The reputation of the meat does not. Humans figured out how to eat it anyway. Inuit communities in Greenland and Iceland developed a fermentation process that involves burying the shark for months, draining out the toxic compounds, and then air-drying the meat. The result is hakarl, a fermented shark dish with a smell so famously offensive that travel writers have spent decades trying to describe it accurately. It is one of the only known cases of a vertebrate predator with flesh too toxic to eat fresh, where humans built an entire food processing tradition around the problem. So what you have taken together is an animal that runs every part of its design backwards from the textbook predator. Slow instead of sleek, blind instead of sharp-eyed, breeding on a scale of centuries instead of decades, poisonous to anything that might try to eat it unless the meat is rotted in the ground for months. And somehow the most successful apex predator in the Arctic deep. Its range covers most of the North Atlantic and the deep waters around Greenland and Iceland. It eats seals and reindeer and the occasional polar bear. It lives for 4 centuries. The biology underneath this is still being worked out. The slow growth and long lifespan are tied to the temperature of the water it lives in. Greenland sharks spend their lives in water that hovers near freezing, between -1 and 5 degrees Celsius for most of the year. Metabolic rates in cold-blooded animals drop sharply at those temperatures. Cells divide more slowly, damage accumulates more slowly, and reproduction is delayed. The whole biological clock is dialed down to a tempo that makes a 0.34 meter per second cruising speed look fast by comparison. Aging researchers have started paying attention to the species in the same way they paid attention to the naked mole rat a decade earlier, looking for cellular machinery that might explain how a vertebrate body holds together for 400 years. The corneal copepod is a separate puzzle nobody has fully solved. The leading theory is that by the time the parasite settles in, the shark has already adapted to a life that does not need eyes, so the cost of